Instead of doing a capture the flag, I'm also going to be doing other things as well, such as creating projects. So this project that I'm going to build is going to be an autonomous red team assistant. This is probably going to be an overview of what will probably be a 15 to 20 episode series building this project. My estimation is that it will take around 40 to 60 hours to complete, but once it's done, I'm hoping to add it to my portfolio. I'll split this into 4 phases. The first phase will be the core engine, and what will be entailed is the architect, project setup, parser, the brain, the system prompt, the first live run. So all this, each line is probably 1 episode. So this is about a 5-step episode for the first part. Today we will just be looking at the project setup, Nmap, Python integration, and environment hardening. So the command that we just ran was done to create a contained laboratory for the project. It ensured that whatever libraries or tools that we install for this project doesn't interfere with the computer's main Python setup or other assignments. On Linux, the command is source venv /bin /activate. We are going to install the essentials. Installing the essentials means downloading the foundational building blocks libraries that allow your Python code to interact with external tools. Without these, your script is just a text file. With them, it gains the power to scan networks and think using AI. When you run pip install, you're using Python's package manager to go to a massive online warehouse, PYPI, and download pre-written code. Efficiency. Instead of writing thousands of lines of code to handle network packets or AI neural networks from scratch, you import the networks others have already done. So essentially, Python Nmap runs the scan to find open ports and service versions. The script that we will make cleans up that data, and Ollama receives that data and acts as a senior penetration tester to tell you what those versions mean in terms of security risks. Cool, this is exciting. To verify that it's been activated, you run nmap --version. Cool, and if it spits out a response, then it's been activated. Now we need to create the scanner script. Okay, so to create a new file, we use the command touch. Okay, so essentially these are the different ways of creating files. So you have touch, which creates an empty file or updating timestamps. And will it override existing content? No. Then you have the greater than symbol, which creates a blank file instantly and it wipes the file. You have code, which is heavy coding with a full graphical user interface and it doesn't overwrite existing content. You have nano, which quick edits on remote servers. No again, and echo, adding a single line of text quickly, only if you use so it will override existing content if you use the greater than symbol, but if you use 2, it just appends to the end. So let's create the file. And let's start opening it up in a graphical user interface. Looks like I need to install it. Okay, so just took a little break while it was downloading, but now it's downloaded. So let's go again. Code. Nice. So it opens up VS Code. Okay, so I've got the file and folder set up. Now I'm going to start writing the code. So here is the code. I'll try and explain it to you. So the first thing that we have is the setup. Import Nmap at the very top pulls in the Python Nmap library we installed. It allows Python to talk to the actual Nmap program on our Kali system. Nm equals to nmap.portscanner in brackets creates the scanner object. Okay, think of it as opening a fresh instance of Nmap that our script can control. This is the most important line in the whole file. It's nm.scan inside brackets target underscore IP comma argument equals in quotes dash s capital V dash T4 close brackets. So target IP, this is the address you want to check, and SV stands for service version detection. Instead of just seeing that port 80 is open, Nmap will probe the port to see exactly what is running. Example, there's Apache 2.4.41. This is the data your LLM needs to find vulnerabilities. -T4, this is a timing template. Nmap has speeds from 0 to 5. T4 is aggressive. It speeds up the scan significantly, which is perfect for labs and capture the flags. The Nmap returns data for every host it finds. If you scan an IP that doesn't exist or is blocking your pings, Nmap won't have a host entry for it. This check prevents your script from crashing if it doesn't find anything. Okay? The entry point. If underscore name equals main, this is standard Python practice. It ensures that the scan only runs if you execute this file directly using python scanner.py. So the target is 127.0.0.1, which is just a placeholder for the moment. So results equals to run underscore scanner target is the trigger. This line is where you actually execute the scan and capture the information. In programming, things don't always go to plan. The if results block ensures the script doesn't crash and burn if a scan fails. In Python, an empty dictionary or none value is considered false. If the scan failed, maybe the host was down, your run underscore scanner function returns none. By saying if results, you're saying only run the next two lines if we actually got data back. I wanted to quickly detail what Nmap is. So Nmap, short for Network Mapper, is the industry standard open source tool for network discovery and security auditing. If a network is a large office building, Nmap is the professional inspector who walks through the halls to see which rooms are occupied, which doors are unlocked, and what exactly is happening inside those rooms. The four main pillars of Nmap: host discovery, identifying which devices, computers, servers, IoT devices are currently active on a network. Determining which ports on those devices are open. Ports are digital gateways for specific types of communication, e.g. port 80 for web traffic, port 22 for remote access. Service and version detection. Once a port is found open, Nmap probes it to identify what specific software is running and its version number. This is the gold mine for penetration testing, e.g. open SSH 8.2p1. OS fingerprinting. By analyzing how a device responds to certain packets, Nmap can accurately guess the operating system, Linux, Windows, Mac, or specific router firmware. In the context of your technical work in cybersecurity and pen testing, Nmap acts as the eyes of your script. Raw intelligence. Nmap provides the specific version strings that allow your AI brain to function. Automation. By using the Python Nmap library, you are automating the manual process of reading Nmap reports. Vulnerability mapping. In your projects, the version detection -SV is the most critical part. It allows your agentic AI to look up specific vulnerabilities related to that exact software version. Fun fact, Nmap is so iconic in the cyber world that it has acted in movies like The Matrix Reloaded and Ocean's 8 to make the hacking scenes look realistic. That's pretty cool. I'll have to look that up. So far today, we've outlined what this series is going to entail, and we've essentially just downloaded the requirements and we've just created the scanner, but there's a few more things that we need to do, such as cleaning the function, so like refining the data, updating the main block, and testing it. But I'll probably do that in a couple days, maybe tomorrow, because I've got some uni classes to head to. But yep, that's all for this live stream. Thank you very much.